Hi, my name is Max. I am a CTO at Augmented Pixels. Today, I'll talk about solving real business problems with the help of our solution featuring 3D map crowdsourcing, localization, and navigation. So today, I'll start from the presentation. If you have any questions, you can ask them later, or you can write them down into the text chat, and I'll read them again in the end, and we'll try to answer them. First, a brief intro about our company. We started back in 2013 in Palo Alto, California. By the time, we raised over $7 million and already done quite a lot. We work with Tier 1 enterprises, including LG, Intel, Qualcomm, and others. We are a founding member of OpenAR Cloud and Open Geospatial Consortium. We have our own proprietary SLAM and cloud localization solutions. I'll talk about them later. Our long-term vision and goal is to build a world where people can cooperate and create new knowledge on the same Earth scale 3D map using smartphones, AR glasses, and robots. We are building a metaverse step by step. We are disrupting an old-fashioned mapping industry via precise indoor AR navigation and 3D mapping crowdsourcing technologies. To do that, we have two solutions. The first one is a B2B solution called CorpMap AI, which is used by companies that have lots of facilities and want to optimize their management and logistics. The second solution is a B2C solution called Global Map AI, which is our long-term project to build a 3D map on the whole Earth. This solution dramatically reduces a map creation cost by leveraging a crowdsourcing approach. Our solution solves problems of different industries, including healthcare, real estate, hospitality, and many more. And now let's see a short demo. This is a video of our working solution where you can see the whole pipeline in a nutshell. First, you create a 3D map of your building. Then you set up points of interest using our web platform. After that, you can localize and navigate in AR to points of interest. Now let's talk about the tech that empowers our solution. Our solutions are based on our own proprietary technology. That is why we have a full control over their tech stack and are able to seamlessly integrate all the components that suit our needs the best. And now let's dive deeper into our technology stack. The first one is our SLAM SDK. This is our first product that we introduced back in 2018 for an inside-out tracking and mapping. From the very start, our SLAM works on all kinds of platforms: iOS, Android, AR glasses, robots, and drones. If your system does not have own positional tracking, such as ARKit or AirCore, you can use our SLAM instead. This makes our solutions, such as Navigation Sdk, truly cross-platform. Our SLAM has a 3D mapping support. It has accurate and power-efficient tracking with low latency. It is robust to difficult conditions, such as rapid motion, moving objects, and textureless environments. SLAM works with lots of different sensors, such as cameras, both mono and stereo, IMU, wheel encoders, and LiDARs. And now let's talk about our main technology, Navigation SDK. It has a lot of different use cases in retail, facility management, onboarding, and so on. For example, in retail, you can do a location-based advertising with centimeter accuracy or perform a foot traffic analysis. With 3D map crowdsourcing, one can cheaply create a facility digital twin using which users can create location-based maintenance reports or tours through the facility. Our platform can be used for the new generation of location-based gaming that requires precise content placement and Earth-scale 3D map. Our Navigation SDK provides a new level of services for the meeting room reservation and booking software. Corporates are using our Navigation SDK to develop a new generation of AI training assistance courses and onboarding procedures. Navigation SDK consists of 4 main components. The first one is our mobile module called Mapper. The main purpose of this module is to do crowdsourced mapping. The Mapper module uploads all the data to our AR cloud. The cloud consists of services for mapping, navigation, and all other data management. Once you have a map, you can manage it using our web CMS front end. Using this, you can add visual content, view analytics, manage users, and many more. To use our SDK with your own solution, we have a cross-platform navigation plugin, which is embedded in your app and has all the necessary navigation features. Navigation plugin is also used for crowdsourced map updates using data collected during navigation sessions. Our navigation system is very capable with centimeter accuracy, low network bandwidth, and robustness to hard conditions. The mapping system is also very efficient because of very low cost for mapping creation and keeping it up to date because of crowdsourcing. Such system performance is achieved through our own proprietary SLAM that uses multiple sensors. While each sensor has its own pros and cons, fusing it all together allows us to get really good results. Now it's time to demonstrate how our pipeline works. First, let's log in and do an overview of our web CMS. Here you can see the map with all locations created in your organization. You can check particular location and see its 3D map and content on it. Here you can see our office in Palo Alto. You can also see all crowd uploads from this location. Okay, and now let's move on to our pipeline. Here you can see overall workflow. Everything starts from location creation, where you upload all your maps, process them, and add content. When all set, you can use localization and navigation. Let's dive deeper. The first step is to create a new location. You have to enter its name and select position on the map. Location address is picked automatically based on its coordinates. You can always change all the info if you need that. Okay, so we created an empty location. Let's fill it with the data. First, log in into the Mapper app using your registered account. Then navigate to a desired location and start a new mapping session. Right now, we are walking around the desired space until the blue regions become colored. That's enough for now. Let's save the map and upload it to the cloud. Once the map is uploaded, let's wait for a moment until it is ready. You can always check the process both in mobile app and web CMS. Okay, the map is ready. Let's see how it looks. Okay, let's move on and add more data. To do that, you use the mobile application again. The process is the same as before, only now you have to localize on the previously mapped area first. Okay, we are localized. Let's map a new space. Now save it and upload to the cloud the same way as before. We can repeat that process as many times as we need. Now let's see what is happening on the web interface. After several mapping sessions, we already have multiple pending maps that we need to merge. You press merge button and wait. It will take a few minutes. Okay, now the map is ready. Let's add some content to it. We start from the navigation rows. This is a graph that is used during navigation pathfinding. Make sure it covers all your mapped spaces. After adding navigation, we add some points of interest and name them. Points of interest can be of different types: rooms, equipment, and even an office cup. Okay, saving. And now the best part, navigation. Localization took about 2 seconds. After that, we can find the route to a desired destination. You can see how precise navigation is. We came exactly where the point is. Okay, and now let's talk about Navigation SDK integration in your own app. To get access to our Navigation SDK, send us an email and we will provide it to you. We will also set up an organization and account in our system. To get started with integration, go to the Web CMS Applications menu, then create a new application. Your organization may have several applications in case you need it. Now copy an application token. The code integration is very straightforward. This is an iOS example, but an Android version is pretty much the same. Just paste your application token in the code. Then create a navigation window and show or hide when you want it. An application window goes full screen when opened. That is that simple. Our solution has other useful features. The first one is location sharing. Mechanism is very simple. You create a link that you can send to your friend via any messenger. Once a person received a link, it can be opened with our Navigation SDK that will create a route to the shared location with centimeter accuracy. Another useful feature goes with our web interface. We can integrate our system with the third-party CRMs and support their management structure. As an administrator, you can create different user roles with specific access rights. You can assign your organization members to a specific location and many, many more. Thanks for your attention. I'm happy to answer all your questions. Yeah, that's it. Okay, the question is there any way of using Slam SDK in a web-based AR app? Well, right now, it is not supported. To use our application, you need to have a native plugin in the target platform, whether it's iOS or Android. But of course, we are planning to integrate our solution with the web-based approaches. The second question was, what is the performance of the algorithm in open spaces? if you're next to building but turn around and there is a large open space in front of you, will be tracking lost easily. No, the tracking won't be lost because of the very high robustness of our odometry. So for example, if you localize, you go to the unmapped space. So for example, there is no map at all, or the place is very wide. So like you asked, we can still track your position for a very, very long period of time. And when you return back to the position where the map is present, we can relocalize and continue mapping with better accuracy. We are also leveraging different sensors, such as not only camera, but also magnetometer and Wi-Fi, and it also increases the robustness. Yeah, the next question is, there is a limit to size of the place you can scan. Can you elaborate more, please? You mean the area of the place? So if the question is, yeah, the area. So right now, we tested our solutions on the areas about 10,000 square meters. In the nearest future, we plan to do that unlimited, so Earth scale. But now practical area that we really support is about 10,000 meters, 10,000 square meters. Yeah, thanks. You mean navigation? The question is, can it be used for multi-users as well? Well, of course. So it's by design, it is multi-user, meaning in one single point of time, we can handle hundreds of parallel navigation sessions. So this is a question of scaling. As for the mapping goes in the order in which you upload the map. So for example, if there are two persons who do the mapping and they both upload the map, we first merge the map that came first and then second, third in this order, in the order of arrival. The question was, can you export the scanned maps? You can export some parts of the maps. So our maps are multi-layered. So we have a SLAM layer. It is proprietary layer that can be exported. We have a magnetometer layer, Wi-Fi layer, different other layers. And we also have a 3D layer, which is basically a textured mesh in a very common format like OBJ or PLY or FBX. So if you are talking about textured mesh, yes, we can export the 3D model with textures in some common format. Yeah, the next question is, how do you handle changes in the physical space? Can the merge get out of sync? Yeah, so the merge always gets out of sync. This is the main, because we treat the map as a dynamic entity, because the map is always changing. So for example, if I map this office, the table or the armchair are sitting on one place, and maybe in 2 hours they will be in absolutely different places. To handle this, we are doing different computer vision stuff like image segmentation, 3D map segmentation. We try to understand which parts of map has changed. If this part of map was changed, we are using crowdsourced data to update it. So this is like the part of our crowdsourcing engine. This is actually the main purpose of it, to update the map during it is changed. Any other questions? How can participants of the challenge gain access to the SDK? So I have a slide for that. You just need to write us an email and we will provide it to you. So right now our SDK in the closed beta, and we share it by request. The question is, you talked about integrating with other content management systems. Can you talk more about that? Do you support any 3D object placement? Okay, first of all, what can you please elaborate more? What is a 3D object placement? So, for example, when I'm talking about different content management system, I'm not talking about 3D object placement. I am just talking about different inventory systems. So, for example, if you have some shop or I don't know, store, you have some system that is already used by this business. What we can do is to create adapters that will transform, that will import data about that inventory system inside our system. So, for example, you have some external database with all the items inside. We can export that database. We can import it as the objects inside our system, like points of interest. And then some manager using our web CMS can place those objects in some specific special locations. And also it is about different organizational and managerial structure. So because we have a very flexible system for that, we can also, I mean, the users can also adapt it to almost any system that is used outside. I mean, sync it with that system that is used outside. I hope I answered your question. Okay, the question is, for the SLAM SDK, is the context of global map AI, does the SDK enable the user to get some form of location response like geopause? 1 second. Well, yeah, we actually have another feature I didn't mention in my presentation. We call it geo report. So actually, what it does, it gives you your position on the map in the global space. So yeah, we can export your position like global one, not in the map space, but in the global Earth space. We are doing all of our maps are aligned with the geographical map. And by doing this, we can transform local map coordinates into the global coordinates and give it to you, like GPS coordinates. Any other questions? Yeah. Also the facing direction, because our maps are aligned to the north. So they are like positionally aligned and rotational. So the heading is aligned with the true north. Yeah. waiting for more questions. Do I have to enter Discord channel to see more questions? Did I understand you correctly? Ah, okay. Okay, so if there are no questions, then thank you for your attention. Goodbye.
Thank you very much, everybody.